66. Okay. Let the people join. We'll start our lecture. Good morning to all of you. Am I audible?
Yes, sir.
Okay. For yesterday's lecture, what we have seen is the factor of safety, some basic definition of that factor of safety. Also, we have taken one practical example by means of which we have seen what the factor of safety is. And I think we have gone through this slide, the margin which is you are going to keep, that margin you are going to say as a factor of safety, which is governed or which is regulated by means of government codes, laws, or design requirements. Okay. Next slide. When we are going to calculate the factor of safety, at that time we can convert that definition or whatever may be the physical significance of that factor of safety into mathematical terms, so that further calculation will become easy, because just what we have to do is that we have to calculate stress, we have to calculate dimensions, and we have to go for drawing of that component, so that we need to have the detailed dimensions of that component. So mathematically, if you are going to say the very basic equation to calculate the factor of safety is to divide ultimate, that is maximum stress, by the typical, or it is called as working stress. Now we are moving towards the engineering side. So first part what we have seen is what the general thing which we have seen regarding the factor of safety. But when we are moving towards the engineering side, then we are knowing that what is ultimate stress. In case of brittle materials, it is going to become ultimate stress, right? And in ductile material also, we are going to get this stress strain curve, and that stress strain curve is going to differ in ductile and brittle materials. And we are knowing what the properties are of ductile and brittle materials. So yield strength and ultimate strength, these are the two categories what we are going to get for the brittle material and for the ductile material. So when we are going to see, when we are going to find out the actual value, then just we can refer that stress strain curve for the given material, because after all, this ultimate tensile strength or yield strength is going to become a material property. And every time it is not necessary to go, if you are choosing a standard material, then every time it is not necessary to go for calculation once again that ultimate tensile strength or that yield strength. So we can use that standard yield strength, ultimate strength, and if we are going to divide it by the working stress, whatever may be the stress which are supposed to occur in that component, if we are going to take that ratio, then we are going to get the factor of safety. Now, the factor of safety is decided. Let me again clarify it. The factor of safety is decided. It has not any standard value. It is depend upon designer. In some cases where we are going to refer the government significance, government codes, in that case it is recommended. The factor of safety value is recommended, but it is up to the designer that how much factor of safety he want to put. Okay, so factor of safety is one. That means the structure or component will fail exactly when it reaches to the design load. That is nothing but if suppose we are designing any component for 10 kilonewton, and if you are putting factor of safety as a 1, then when this value of load becomes 10 kilonewton, then it will reach to its maximum stress value. That component will reach to its maximum stress value and it will get failed. So definitely when we are supposed to work for that 10 kilonewton, our component should sustain that 10 kilonewton. Then one has not to assume that it will be break at 10 kilonewton because it has to work in that 10 kilonewton load or it has to sustain that 10 kilonewton load. So definitely that value is more than 1. So when we are going to design, when we are going to select this factor of safety, at that time, this factor of safety should be more than 1 or at least 1. Yesterday also I told you that if suppose factor of safety is going to become less than 1, it means that before reaching to the rated load of that component, it is going to get failed. So factor of safety should be 1 or more than that. Always in various cases, it is not also 1 also, it is more than 1. Then next, when we are going to calculate factor of safety by considering the force which is applied. Now this force which is required to fail that component, that is, we will call it as a F suffix fail, and the force which is allowed to apply on that component, that will say as a F suffix allow. Then mathematically this factor of safety value can be written as the force at which that component gets failed divided by the force which is allowed in that component, or force which is allowed to apply on that component, not in that component. It is the force. When we are applying force, stress will be generated. So that will be induced in that component. Okay. So we are going to say the force which is allowed to apply on that component. That we are going to get as a factor of safety. Now this is related to the force which is applied. Factor of safety is related to the force which is applied. Next slide, when we are talking in terms of stress. Now again we are going to consider the stress as a compressive tensile stress. Compressive and tensile stress are nothing but the similar one. Only thing is that when compressive force is applied, compressive force stress are generated. When tensile force is applied, tensile stress is generated. Some material properties are such that they can sustain more compressive stress rather than the tensile stress. For example, RCC structure, that is reinforced steel structures. So in that case, cement structure actually. So in that case, they are able to sustain compressive load. More compressive load they can sustain, more compressive stress they can sustain. But when we are elongating it, their strength will get reduced, or it is less than the compressive strength. So you might have seen advertised of Virat compressive strength. So that compressive strength, that is nothing but they are capable to sustain the compressive load, but they are not capable to sustain that much as compared to the compressive load. They are not able to sustain tensile load. So we are talking about this plane stress, that is tensile or compressive. When we are calculating this factor of safety related to the stress, plane stress, because force divided by area gives us stress. So in that case, as already we have seen the value of factor of safety in terms of force, just we are going to convert it mathematically in terms of stress. So let us consider that sigma suffix fail is the failure normal stress in Newton meter square or Pascal, and sigma suffix allow is allowable normal stresses, which are again in Newton per meter square or in Pascal. So when we are going to write the equation, this equation for factor of safety, it will become the sigma which is required to fail that component to the sigma which is allowed in that component. It means that already we have taken example. This sigma allowed is nothing but your 1000 rupees which are required to be spent when you are going for the visit. And this sigma fail is nothing but the value which you have put in your pocket, the amount of money which you are going to put in your pocket, and that you are going to consider as a 1500 rupees. So this 1500, after 1500, once you are going to spend that 1500, you will not have any single rupee to be spent. So in that case, we can consider that our wallet gets failed. So that value is nothing but this sigma fail. And allowable, the total expenditure which we have calculated for the visit, that is nothing but 1000 rupees that you are going to say as a allowable. Okay, or design, again we can use another word for that, design stresses. So that component should not go or should not undergo to the stress beyond the allowable stress. But in some cases, because of the accident and all that cases which were not predicted or which are not in our hand, if the stress value get increased, then also our component will sustain the stress by means of this factor of safety. And this value of factor of safety is calculated in terms of this normal stress as a normal failure stress divided by normal allowable stress. Okay. Next, this same formula, just what we are going to do is that we are going to calculate the same formula, same value by means of taking some references. As we have taken force in this case, then here we have taken normal stresses, then we'll take shear stress as a criteria of the failure, because some components are undergoing for the shear. For example, if we are going to consider the shaft which is transmitting torque, and if we are going to mount gear or pulley on that shaft, then that pulley will try to shear out that shaft. It will apply its own weight as well as the force or the tensile force which is applied because of the belt or because of the gear also. So it will try to shear out that shaft. Other example, nut and bolt. If we are going to fasten two different shafts or two different parts together, then there may be possibility that this nut and bolt assembly, or out of that, the bolt will get shear because of the shear stresses. In that case, shear stresses are major stresses. So when we are talking about the shear stress, then that shear stress are also responsible, and we can take into account of that shear stress. So let us consider that this tau suffix fail is the failure shear stress in Newton meter square or in Pascal. Now, while we are calculating this all values in mathematics, at that time you have to take care of these units. Okay, so one has to always see the units while we are doing the calculations. Otherwise, your result may get deeper, or we may get the wrong results if you are not concentrating on the units. So we'll consider this tau suffix fail as a failure shear stress in Newton meter square or Pascal, and this tau suffix allow, we are going to consider that allowable shear stresses in Newton per meter square or Pascal. So in this case, if you want to calculate the factor of safety, it will be failure stresses, that is failure shear stresses, divided by allowable shear stresses. And this value should not become less than 1. If we are saying that this value is 0.9, it means that this denominator is higher, that is allowable stresses are higher rather than this failure stress. So it will be definitely get failed, because These allowable stresses are reaching to the failure stress and going beyond that. So definitely this part will get failed if the factor of safety value is less than 1. So this is in terms of shear stress. Now, just we have calculated for the normal and shear stress. Now, when we are going to say that we are just in need of calculating what are the design stresses, because once you are going to get the value of design stress, then further we can write equation that design stress is equal to design load divided by area, and we are interested into calculation of that area, because load which is coming, that we may calculate, we may take data from previous or what we can say previous tests as well as the previous experience, how much load will come. Suppose we are going to design a footrest. At that time, one can get that how much load may apply on that footrest by means of taking previous data. Here I want to tell you one example. Before that, let me finish this slide, and later on we'll go to the example. So when we are interested to calculate this design stress, at that time the material property is available in standard design data book. So we will choose this SYT, that is yield strength of the material which you are going to choose, if that material is ductile material. And in case of brittle material, we are going to choose it as a SUT, ultimate tensile strength. Now, let me explain one more difference in this brittle and ductile materials. In case of ductile materials, if that material or that component starts to yield, that is, if the expansion or that change in shape of that component goes beyond its elastic limit, if it goes to the plastic stage, then it will not regain, it will not come to the original position. So as it is considered as a failure, though physically it is not break into two pieces. Then also, if it start to elongate, we are going to consider it as a failure. For example, suppose we are going to have one pin, shear pin. Everybody might have seen drawer and trolleys of tractor. Let me shift in Marathi, please allow. आपण ट्रॅक्टर आणि ट्रॉली जोडताना मध्ये एक पिन टाकली जाते, आणि ती पिन जर फेल्युअर झाली नाही, दोन तुकड्यामध्ये डिवाइड झाली नाही, फक्त ती इलॉंगेट झाली, ड्रॉबार पुल जे आपण जोडलेलं असतं त्याला मराठीत आपण दाबर म्हणतो, ते जर इलॉंगेट व्हायला लागलं, म्हणजे आपण ट्रॅक्टर चालू केलाय पण ट्रॉली जागची हालत नाही, आणि जी पिन बसवली ती पिन आहे ती फक्त इलॉंगेट व्हायला लागली, शेअर फिजिकली ती शेअर झाली नाही, then also it is considered as a failure. That means it is not capable to sustain that load. That is the property of ductile materials. They will not get fail, or it will not break into two parts. But before that, they will go to the plastic stage. That means they start to elongate. In elastic limit also they are elongating. But when you are removing that load, they are going to regain their original size and shape. And it is allowed. But if it goes to the plastic stage, then it is considered as a failure. That is not case for the brittle materials. In case of brittle materials, we are not finding that plastic stage, elongation stage. Directly, if the stress is reaching to the ultimate stress, that part is going to get break into two pieces, and we can observe that it is that breakdown has happened. That part has get failed. So that's why we are going to consider these two different strengths. That is this yield strength as well as this ultimate strength. Okay. So this design stress can be calculated as ultimate tensile strength divided by this N. Now this N is used for the factor of safety, value of factor of safety. Now this N will be decided by means of designer. On what basis you are going to decide that value, that we will see further. And here in case of ductile materials, sorry, this we have seen for the ductile materials and this for the brittle materials, this design stresses are equal to ultimate stress divided by factor of safety. Now, the basis which we have used, that is ultimate and yield strength, they are totally different, and one has to have the experience that this value of N may not be same in case of ductile materials and in case of brittle materials, because ductile materials are allowing us to have some time before they get break, before they get have the total failure. But brittle materials, they are not going to give us any chance. Directly, they are going to have the two pieces. They are going to get break, and there may be severe accident in case of brittle materials. So while choosing the factor of safety for the brittle materials, definitely that value should be higher than the value which you are going to choose for the ductile materials. That will become by experience. Okay, but keep in mind, as you are knowing the properties of material, so in case of ductile materials, that value may be somewhat less as compared to the brittle materials. Okay, we got this concept of factor of safety. Now here, in this case also, if you want to calculate the design stress, this allowable stress are nothing but the design stress. Just take this value to the other side of equality and divide it by the factor of safety. That's what I have done in this case. Now this is we have calculated for the normal stress. Same way we can calculate for the shear stress also. If you want to calculate this design stresses, shear stresses which are induced in the component, if it is undergoing for the shear force, then this allowable or design shear stress is equal to the failure, that is ultimate, which you are going to consider, divided by factor of safety. So from this slide, that is while considering the force, we are going to have same formula, but it has been used for the different criteria. That's all. It is the same formula. Okay. Now let me tell you one example, which actually has happened in Mahindra and Mahindra. And one of my friends who was working previously with the Mahindra and Mahindra in 2001, and he was in design department. So at that time, Trax was the competitor for the Commander Jeep. Commander, you might be knowing that Commander is a model of Mahindra, and Tempo Trax is the model of that TACO company. So, and both of that automobiles were used for the public transport. That Mahindra Commander Jeep and that Trax. And at that time, the footrest which was designed for the Commander, that rear end footrest, you might be knowing, we are going to put our feet on that and we are entering in the Jeep from the back side of that Jeep. And as it was used for the public transportation, we call it as, in Marathi as a vadap. Okay. तर त्या वडापसाठी ती वापरली जायची. And you know, for getting more money, that driver of that Jeep was allowing to more people than the recommended people. Actually ती असते 2 2 4 4 8 10 म्हणजे 9+1 साठी आरटीओ पासिंग त्या कमांडरचं 9+1 आहे. बट आपण वडापसाठी वापरलेल्या गाड्या बघितल्या असतील तर त्याच्यात 14 20 अशी लोक भरली जायची. आणि त्यातल्या त्यात त्या मागच्या फुटरेस्टवर पाय ठेवून वरती धरून असे 4 लोक 5 लोक तो ड्रायव्हर बसवायचा. आणि कमांडरचे मार्केटमधनं आलेला प्रॉब्लेम हा आला की ते फुटरेस्टच टिकत नाही. आता बिचारा डिझायनर जो कंपनीत काम करतोय आणि तो केबिन मध्ये बसून ज्यावेळेला फुटरेस्ट डिझाईन करेल त्यावेळेला त्याने किती लोड कन्सिडर केला पाहिजे. कॅन यू गिव्ह मी आन्सर? what you will do if you are a designer and you are just designing the footrest? Who can give answer? How much load we have to consider? एखाद्या गाडीचा फुटरेस्ट आपण डिझाईन करतोय, जसं की आपण कमांडरचं उदाहरण घ्या, त्याच्यावर पाय ठेवून आत बसायचं असतं. हा कॉम्पोनंट आहे. तर त्यासाठी आपण जर आपण ते डिझाईन करायला लागलो, त्याची डायमेन्शन्स कॅल्क्युलेट करायला लागलो, लोड किती कन्सिडर करणार? एनीबडी?
जितका सगळ्यांना सस्टेन होईल तितका करणार.
बरोबर आहे. पण आपण ज्या वेळेला तुम्ही एक इंजिनियर आहे आणि तुम्ही हा डिझाईन करताय की एक माणूस त्याच्यामधनं आतमध्ये बसतोय. ऑब्विस आहे की व्हाईल यू आर डिझायनिंग ऑटोमोबाईल यू आर कन्सिडरिंग दॅट एका वेळेला एक माणूस त्याच्यामध्ये चढून बसतोय. मग आपण एका माणसाचं मॅक्झिमम वेट कन्सिडर करणार. सपोज फॉर इंडियन टेरिटरी वी आर गोइंग टू कन्सिडर दॅट वेट ॲज 120 kg. आपल्यातला सगळ्यात हायेस्ट जो अवजड माणूस असेल दॅट हिज वेट मे बी 120 आणि त्याच्यापेक्षा जर जास्त असेल लेट इट बी. So when we are using that 120 as a maximum load, okay, and if you are using factor of safety as a 2, कुलकर्णी आता तुम्ही म्यूट करा. We are listening background noise. Okay. We'll consider that 120 kg is the maximum load which may comes at a time on that footrest. And as designer, we are going to use factor of safety as a 2. It will become 240 kg. So we'll consider that 240 kg. आता 240 kg एवढा कुठलाही माणूस एका वेळेला त्याच्यावर पाय ठेवून आत जाणार नाही. ते आपल्याला माहित आहे. सुमो पैलवान आपल्याला नाही. ओके, त्यांचं पण वेट 240 पर्यंत जाणार नाही. So when we are considering that load, at that time using factor of safety, and in actual practice what is happening, that 5 people are standing by putting their 1 foot on that footrest and other feet in air, sustaining in air. वडापमध्ये काय होतं की 4 माणसं त्या एका फुटरेस्टवर पाय ठेवून उभा राहिलेत, वरती कुठेतरी पकडले आणि तो वडापावला गाडी चालवतोय. मी तर त्या डिझायनरनं अभ्यास केलेला, डिझायनरनं कन्सिडर केलेली आणि ऍक्च्युअल प्रॅक्टिस याच्यामध्ये खूप जमीन आसमानचा फरक झाला. गेटिंग अँड दॅट्स वाय दॅट फुटरेस्ट वॉज फेलिंग एव्हरी टाइम. वडापच्या गाड्यांसाठी किंवा पब्लिक ट्रान्सपोर्टेशनसाठी ज्या महिंद्राची कमांडर वापरली जायची त्या केसमध्ये कायम ते फुटरेस्ट फेल्युअर व्हायचे. देन दॅट डिझायनर कन्सिडर्ड दॅट ऍप्लिकेशन where that commander jeep was used and he makes changes accordingly. Then he considered that at a time 120 kg multiplied by 4 people, they are standing continuously on that footrest. It will become 480 kg. And then he used factor of safety as a 2. And it becomes 960 kg at a time. And that part was sustaining in the market. So that is the beauty, how we are going to select the factor of safety, what we are thinking by sitting in the cabin, and what marketing people are expecting from us, what actual that working conditions are expecting from us. So likewise, all these incidents we have to consider while we are choosing this factor of safety. Let us move further to the further slide. Now, next part that what I was talking about is the factors on which this factor of safety is dependent. Now, in the example which we have seen, त्याच्यामध्ये त्या बिचारा डिझायनरनं तो फॅक्टर कन्सिडरच केला नाही की एका वेळेला 4 लोक त्या फुटरेस्टवर पाय ठेवून उभा राहतील. त्यामुळं त्याला मार्केट किंवा ऍक्च्युअल कंडिशन, ग्राउंड कंडिशनची आयडिया आली नाही. बट व्हेन that complaint comes from the marketing people, and when that designer think about it, when he got that experience, then he decided that yeah, this is the condition and we have to make this footrest more robust, more sustainable. And that's why he considered that factor. Likewise, there are some standard factors which that designer has to be considered while he has to choose the factor of safety. Out of that, material is very basic concept because strength is depend upon that material. If you are choosing steel as a material and if you are choosing wood as a material, both of that material will have different strengths. So one has to consider that the material properties first of all. So strength based on material. Now, in some cases, we are going to say as a ferrous and non-ferrous materials. Now, there are different types of materials which are available in market. So, we'll concentrate on brittle and ductile material. So, while we are choosing that factor of safety value, then we have to take care for choosing of that factor of safety value while we are using brittle material and while we are using ductile materials. So, in case of brittle materials, already we have recommended that ultimate strength has to be used while we are selecting factor of safety. And when we are using ductile materials, at that time yield strength is not necessary to go for the ultimate because ultimate strength in case of ductile material is more than the yield strength. Okay, that is lower value of yield strength. That lower value we have to consider while we are selecting factor of safety in case of that ductile materials. Okay, so this is the first base we have to use while we are selecting factor of safety. Second thing is manner of loading. Now, which type of load is coming on that component? That is affecting on the selection of that factor of safety, value of that factor of safety. That loads already we have seen that static load. If the load is applied gradually, slowly, and remains applied, or it is not having any change with respect to time, then that type of load, in that case, we may have some relaxation. That yes, once the load is applied, that 10 kilonewton, it will remain as a 10 kilonewton. It will not become 9 and later on 10, later on 11. It is not frequently changing. So that's why we can have some relaxation in that case. So that load has to be considered. If the load is repetitive, you might have experience of breaking any wire while you are applying repetitive cycles on that wire. एखादी मेटलची वायर तुम्ही कट करत असताना तिला repetitive stress apply करता, बरोबर आहे का? And you are going to break it. So you are going to, and if you want to break it by means of applying force or by means of tensile force, in huge amount of force is required for that, as compared to breaking it by means of applying reversible cycles. म्हणजे आपण वाकवून जी तार म्हणजे एकदा पॉझिटिव्ह एकदा निगेटिव्ह अशी वाकवून ज्यावेळेला तार तोडतो त्यापेक्षा जर आपण ती ओढून ताणून तोडायची म्हटलं तर त्याच्यासाठी खूप जास्त फोर्स लागतो. So that type of nature is nothing but the repetitive type of force which is applied. Okay, and that repetitive force is having very, very, very low value than that tensile strength. So while selecting factor of safety, we have to consider that whether that part is undergoing for the repetitive type of load. For example, if you are designing any suspension parts, in case of suspension parts, that spring or suspension, it is undergoing for the repetitive type of load. And in that case, it may get failed before it gets strength. So we have to consider that, and that how to design such type of part, that we are going to see further in the next unit. The third type of load is impact type. Impact type of load, we can take an example. Same metal wire, if you want to cut it by means of applying tensile force, same metallic wire by applying repetitive force, and same metallic wire if you want to break it by means of applying force as impact force. म्हणजे एक दगड घेतला त्याच्यावरती ती वायर ठेवली आणि दुसऱ्या दगडाने त्याच्यावर जोरात इम्पॅक्ट केला, then also it is going to break. It doesn't mean that the force which you are going to apply by means of other stone is higher than its tensile strength. But as you are going to make sudden impact, then strength of that wire get reduces. So that type of loads are also coming on the component which you are designing. And in that case, that impact load we have to consider. For example, again, can you give me any practical example? Mirchi Kandap Yantra, where the impact load, continuously impact load is coming. And that part may get failed because of the impact loading. Then there are some applications like this where the impact load is continuously occurring, impact load is coming on that part. So we have to consider that impact load also while we are selecting this factor of safety. So these three types of loads we have to consider, and which type of load is coming on the component which we are designing, that we have to take into account, and then afterwards we have to select the factor of safety. Next, possible misuse. So in our example, we have seen that that designer was unable to consider that misuse of that footrest. But every possible misuse of the component which you are designing, that has to be considered. At least known type of misuse of the components that has to be considered. See, when a component which you are designing is not that much critical, you are not bothering about it. But if it is creating major effect on human beings, then we have to take into account all these things. If the major accident may happen because of the failure of that component which you are designing, or not only for the human beings, if the wealth may get destroyed because of the component which you are designing, or failure of that component which you are designing, then also we have to be conscious about it. We have to be alert about what we are choosing, what factor of safety we are choosing. That's why this factor of safety is the basic thing in that designing. Okay. So possible misuse we have to consider. Then complexity of the stress analysis. Now see, this point is somewhat critical, because in some cases we are not able to judge which type of stress may occur in that component. For example, at the time of accident, we are not knowing that which stress will occur where, because it is an accident. And in that case, from which side that impact may come, from which side or which type of stresses may induce in that we are not able to judge. And it will become more complicated to analyze the stress. Whereas in some applications, that component may be used at very high temperature. Suppose you are designing bike, and that bike is purchased by a person who is living in Rajasthan, where the temperature is very high, desert of that Rajasthan. Whereas same model, same bike is purchased by any person who is living in Kashmir, where temperature is very low. Or again, we'll say who is living in Ladakh, who is living in Nepal, where the temperature doesn't go beyond 25 to 30 degrees Celsius. And whereas the same product is used by means of person who is living in desert of Rajasthan. So environmental conditions are also going to affect. Again, the same product is used by means of person who is living in Mumbai, where the humid environment is there. So rusting takes place. So all these considerations, all these factors, we have to consider while we are choosing the factor of safety. So that part may get failed easily in case of the environment where it is humid, like in Mumbai, whereas it may not get failed at the same level, same number of cycles, or same working time in case of Ladakh, or it may not get failed where in desert of Rajasthan. So environmental conditions we have to consider, that is temperature, weather, then radiations, chemicals, etc. That is, if the component is used in chemical industries where it is always coming in contact with the chemicals which are responsible for the rusting, then we have to choose different factor of safety. Whereas if the component is used in clean environment where it is not coming in contact with any chemical, then factor of safety is different. Because this factor of safety is going to play a vital role. If suppose we decide that the related be, what happens if we are choosing factor of safety as a 5? That part may be used anywhere. So it will become more rubbish. Okay. If the working stress or working force is 10 Newton, we will design it for the factor of safety as a 5, that is 50 Newtons. But when you are choosing that 50 Newton as a force, one more thing, are you able to listen me?
Yes, sir.
So when we are using that factor of safety as a 5, and when we are choosing that design load or load as a 50, then you can see that who is denominator, that is area. And if you are choosing that 50 as a working stress, then 50 as a working load, then area will be more as compared to the load which you are choosing as a 20. And if the cross-sectional area is more, it means that more material you are using. And if more material you are using, it means that more cost. So it will not become cost benefit. So we have to take care. If you want to have the competition in market, then this factor of safety is going to become a very important key point. If you are reducing weight, then you can sell same component with lower cost. Getting me? Okay. Then who is there? Can you mute yourself? We are listening background. Vaibhav, that's up. Will you please unmute yourself? Okay. Now next point which we are going to see is the hazardous of failure. That is very important point. What will happen if the part gets failed? The part which you are designing. Whether it will create disaster or it will have just the intimation of that failure. It will not affect much more. That part, that means that particular aspect is going to affect on the future. Yes? Rohit. That part is going to affect on that factor of safety, or when you are choosing that factor of safety. And already I have talked about the cost. If you are using more factor of safety, cost will be higher. Okay. So today we'll stop here. Let me take present first, and we will go to the next. Do you have a next class?